Okay, hi Year 11. Again, we've got the specification up here of 1C, which is atomic structure, and there are 4 points in atomic structure which you need to know for the exam, your first exam in the first pack. I'm just going to go through the last specification point here, which is calculating relative atomic masses, and that's using isotopic abundances. So that's using the abundance of each isotope. So every element, so these elements are present on Earth in different abundances. There's not just one form of magnesium. You actually have 3 different forms, and they are present in different percentages on Earth. Okay, so we need to calculate the average relative atomic mass of these 3 isotopes of magnesium, which all have a different mass number and also the different abundance as well. So I'm going to show you how to do that, and because your abundance is out of 100%, I like to think about it as we have 100 atoms, and out of those 100 atoms, 79% of those atoms, or 79 of those atoms, so let's say that's around all of these, 79 of those atoms are Mg24. Then 10% of those atoms, let's do it in a different color actually, 10% of those atoms are magnesium 25, and then the last 10 or 11%, let's just say I haven't done it properly right, but the last 11% is magnesium 26. Okay, so to find out the average weight mass of just one of these atoms, we need to find out the mass of the whole of all of the 100 atoms, then divide by 100. So to find the mass of all the atoms, we need to do 24, which is the mass of our magnesium, times by how many atoms there are there, that's 79. We need to plus now 25, which is the mass of our second isotope of magnesium, times by 10. We need to plus, last but not least, is magnesium 26 times by 11, because there's 11 atoms. Now if we divide all of that by 100, we should get the average mass number of magnesium, of all these isotopes of magnesium. Now I'm guessing that's going to be closer to 24. I haven't typed it into a calculator yet, but I'm guessing it's closer to 24 because there are more 24 atoms. There are more magnesium 24 atoms. So I guess it's going to be like 24 point, let's say, I don't know, it's going to be less than 24.5. Let's say 24.3. Let's see what it is. Yeah, it is 24.3. Okay, so here I have some practice questions for you, just going over chlorine. We've used the same method that I showed you in the previous slide, and we've just done 35 times the percentage, 35 times the percentage, and then we've done 37 times again by the percentage, and then we've divided it by 100. We've got 35.5. So that's why in your periodic table some atoms have a point value for their mass number, even though you can't have half protons or half neutrons. This is just because it's an average. Okay, so in a moment now I'm going to give you some time to complete these answers, and I'll say give yourself 1, 2, 3, 4, 5, 6. Give yourself around 6 minutes, about a minute for each. You don't have to do all of them though if you don't want to, because it's quite repetitive. Once you've got the hang of it, you can move on. Pause the video now. Okay, so well done for that. Here are the answers, and they are to 3 significant figures. Now it says 3 significant figures up at the top here. If in doubt, I would say just put to 3 significant figures anyway. Okay, so here we have another specification. This is 1D, this is the periodic table, and this is another part of the spec which is going to come up in your exam. So we're going to go through, I think, like as many of them as possible, but I might miss out some, but you can have a read of them and see if you can tick off all of them yourself. And this is kind of what you want to be doing. You want to be looking through the specification and just ticking off the points that you don't know. If you're a bit unsure on some of them, then just, I don't know, circle them, then go back to them and look through your book and really try and... Okay, so here we have a periodic table. It's not quite a complete periodic table because we're missing the transition metals. The transition metals here, okay, but not to worry. Now, first thing you need to know is where are the metal and non-metals. Now, I know this might be quite patronizing, but I thought so we'll go over it quickly. But the metals and non-metals are separated by this stepped ladder, and it always starts from the left of boron. So if you think of boron as a non-metal and aluminium as a metal, you'll always remember that it's on the left-hand side of boron, that it goes atop from aluminium. You don't really need to know that, to be fair, because it's in you'll get it in your exams, so you'll be fine with that. And left part is metal, right part is non-metal. Now you also need to be able to draw the electron configurations of each of these atoms, which we'll do in a moment. Before, we'll just quickly go over mass number and atomic number. So mass number is the top number. That just tells us the number of, you should be finishing my sentence here, protons and neutrons. Okay, I've put the charges above there to help you. And atomic number, which is also called the proton number, tells us the number of protons, hence its name, which is also equal to the number of electrons because atoms are neutral. Okay, so you have to have the same number of positives as you do negatives. So drawing the electron configuration now, let's do one for boron here. So we're looking at the bottom number, the atomic number, because that tells us the number of electrons. And when we're drawing out the electronic configuration, that's what we need to be aware of. So boron here, 5, it's got 5 electrons because the atomic number is 5. So we're going to be using I'll write it here, 288 rule. So that means in the first shell, you can fit up to 2 electrons. And in the second shell, 8 electrons can fit in the second shell. Then in the third shell, 8 as well. And then your remaining ones are just going to go on the fourth shell, but that's just for potassium and calcium, just for those ones there. So here I'm going to start with, let's say boron, and let's start with doing the electronic configuration rather than drawing the electrons first. So 2 electrons can fit in the outer shell. Then your remaining 3 are going to go in the second shell. So you should have an electronic configuration of 2, 3. So you draw 2 in the first shell, 1, 2, and then you draw 3 in the outer shell. And you always start north, east, south, then west. You always go that way, and then you start to pair them up afterwards. Let's do one for phosphorus, which is in period 3 and group 5. So make sure you do know that period 1, period 2, and period 3 and 4 are on the top, on the side there. Sorry. So phosphorus has 15 electrons. Always do the electron configuration first. It's just so much easier. So you have 2 electrons in the inner shell. Second shell has more than 8, so 8 is filled up. So we have 2, 8. We have 5 left, so that's going to go in the remaining shell there. Okay, so drawing them in, 2 in the first shell, and then we've got 8 northeast, southwest. Start pairing. 2, 8, and then we've got 5 in the outer shell. 2, 3, north, east, south, west. Okay. Now you should be able to see. If you carry on completing them, you should start seeing a pattern, and the pattern just goes. Your group number tells us how many electrons are in the outer shell. So in the outer shell, that's going to have everything in group. All elements in group 5 are going to have 5 on the outer shell. All elements in group 6 are going to have 6 on the outer shell, 7 on the outer shell for group 7, and then you're going to have 0 on the outer shell, or 8, or 2 if you're the top one here. That can be quite confusing. You have to just be careful of that. And then your carbon in group 4 and silicon, group 3, always going to have 3. Then you're going to have 1, 1, 1, 1, 1. Sorry, 2, 2, 2. Then 1, 1, 1, 1, 1 for these ones. Now, the number of shells, the number of filled shells is the number of shells, sorry, is equal to the period as well. So period 1, you just have 1 shell, so you can put square brackets and close them up for the top row. Period 2, you're going to have full shells. 2 shells, sorry, and the inner shell is full, so we're going to have 2, 2, 2, 2, 2, 3, 2, 4. We can close these brackets up. 2, 5, 2, 6, 2, 7, and then for period 3, you're going to have 3 shells. You're going to have 2, 8, 1. Now I'm not going to draw in. Sorry, the electrons, because I think it might be a waste of time. And I think you should get the idea by now. If you don't, feel free to ask your teacher. So we've got 2, 8, 8, 1, 2, 8, 8, 2. Now, the other thing you need to know is that your metals and non-metals, you just need to know about their acid and base characteristics. So your metals form, sorry, metal oxides, your metal oxides are alkaline. So they are alkaline. You actually do need to know this. So it's in your specification if you go up and read your non-metal oxides. So non-metal oxides, therefore going to be the opposite. They're going to be acidic. So you do get metal oxides reacting with non-metal oxides, and that's just because one's acidic and one's alkaline. You may get that in an exam question actually. Why does sodium oxide react with silicon oxide? Or something like that, and you'll say because one's alkaline and one's acidic. So you may get that in the exam. So some examples here are non-metal oxides, a carbon dioxide, sulfur dioxide. These are acidic, and these actually cause acid rain. So it links back to another topic that you've done previously. Metal oxides, again, sodium hydroxide. This does link as well to another topic. Potassium oxide and magnesium oxide. So these are all alkaline. Okay. Then the last thing you need to know are the ions. So group 1 all have one outer electron, which they prefer to lose to gain a full outer shell. So all group 1 elements react in a similar way. They have similar chemical properties because they all like to lose that one outer electron. So when they lose that one outer electron, it becomes a positive. Now when atoms react, it's only the outer electrons that are involved in this reaction. So going to group 2 now, they have 2 electrons in their outer shell. So these atoms like to lose 2 electrons to become a +2 ion. Group 3, they lose 3 electrons. Group 4, they like to share their electrons instead. It's neither easier for them to lose 4 or gain 4, so they like to share it instead and form covalent bonding, which we'll see in the next video. Nitrogen, group 5, sorry, they like to gain 3. So if they gain 3 electrons, they form -3. Okay, and if you're unsure about why they form these charges when they lose electrons or gain electrons, please again just ask your teacher. Sorry, I've put +2, but it's just better practice to put plus, 2 plus, 3 plus, nothing, 3 minus, 2 minus, and minus. Group 0, however, they don't like to react. They're called noble gases, so they already have a full shell. So they're what we call inert or unreactive. Okay.